basic parts of a turbocharger. A turbocharger consists of a compressor housing, compressor wheel, turbine housing, connecting shaft, bearings, and oil seals. The middle part held together is called a cartridge. The compressor wheel and the turbine wheel are connected with a shaft, so that turning the turbine wheel will turn the compressor wheel. A turbocharger is designed to rotate over 100,000 RPM. An oil feed line from the engine will lubricate the shaft and the bearings, providing less friction. Now, let's see how the turbocharger works with the engine. An engine without any forced induction device is a naturally aspirated engine. The air is pulled in through an air filter by the suction force of the piston. Then it gets mixed with the fuel, compressed, and gets ignited. With the turbocharger introduced, the exhaust gas from combustion turns the turbine wheel. This turns the compressor wheel, and more air is compressed and fed to the engine. Let's take a closer look. The exhaust gas from the engine will push the turbine wheel, and this turns the compressor wheel, forcing more air into the engine. According to gas laws, for a constant volume, increasing the air pressure will increase its temperature. So there will be a difference in temperature after charging. Forcing this air into the engine can reduce efficiency and cause knocking. In order to cool this air, an intercooler is introduced. An intercooler is an air-to-air heat exchanger device, which helps to cool this air before it enters the engine. So introducing an intercooler into the system will increase the charge density by cooling the air, and provides volumetric efficiency. In conclusion, a turbocharger will provide more air to expand on combustion and produce.
This video illustrates the components of a Mala outlet standard thermostat and demonstrates how it works in an engine's cooling system. Mala original thermostats utilize a wax element where special wax, compounded to melt at a specified temperature, is contained in a brass cylinder. A piston and a small rod on the piston complete the assembly. Expanding melted wax moves the piston, which opens the valve. The spring closes it as the wax cools down. The entire valve unit is inserted into a housing to form a complete thermostat assembly that includes a chamber where cold and warm coolant are mixed properly. Here you can see that when the engine is first started, the coolant is cold. The wax is solid, and the thermostat valve is completely closed. All coolant is routed back into the engine. As the coolant begins to heat up, seen here by the change in color, the thermostat partially opens. And allows some coolant to flow into the radiator. And some to bypass the radiator and flow back to the engine. When the engine gets hotter and more cooling is needed, the bypass valve closes 100%. And all of the flow goes through the radiator. Based on the air temperature, engine load, and operating conditions, the thermostat typically fluctuates in some position between fully closed and fully opened to maintain the desired engine operating temperature. Mala is a large supplier of OE thermostats to both car and truck manufacturers. You can count on Mala original replacement thermostats to be of the same quality and design as the OE part.